Okay, let's look at this question. This is question 8. Let's say diagram below shows the graph of y, the g prime. Remember, this is the gradient. The gradient of g of this cubic. Then the graph of g graph, the gradient cuts y-axis at 0 at 1. This is the y-intercept of this graph, the derivative, and the x-axis at negative 1 over 3 and 0 and 1 over 3. Now remember, here we're dealing with the g graph, the gradient. This is the gradient of the parabola. So now let's look at question 8.1. Write down the coordinate of the stationary point of g. Stationary point of g. Now what happens at the stationary point of g? We know that at the stationary point of g, at the stationary points g prime of x, it is equals to 0. This is 8.1. Then with 8.1 is our 8.1. We know that at the stationary point g of x is g prime of x, it is equals to 0. We know that. So now let's look at this g. Where is this g0? G is 0 here. So now these are the coordinates of stationary points of this. So these coordinates here, we have x as negative 1 over 3 and x is equals to 1. We don't have y values. We can't get the y values now at this point. Why can't we get them? Because we don't know the equation. So we just need the x, write down the coordinates, but it said the coordinates of the points. So we have these stationary points here of g. Stationary points of g is x is negative 1 and x at 1 and x at negative 1, because the g prime must be 0. But now we have what? G of 1. Now g of 1, we don't have g of 1, we just have a y-axis of this. So g of 1, we don't have it, and g of minus 1 over 3, we don't have it, but I can write them as negative 1 over 3 and g of negative 1 over 3 and 1 and g of 1, because I must take them to g. Okay, now let's go to 2.2. Determine the point of inflection. What's happening at this point of inflection? Concavity change. As I can see here, this is concave up, concave changed here. This is concave down. So concave is changing at the midpoint of this, at the midpoint of the turning point. So that's where my concavity is changing. So I'm looking at 8.2. My concavity is changing between the 2 coordinates. So this is going to be 1 plus minus 1 over 3 over 2. That's the midpoint. It changes at the midpoint of that. So that is 1 minus 1 over 1 minus 1 over 3 divided by 2. That is giving me 1 over 3. So my exact 1 over 3 is where the concavity change, or the point of inflection of this is at that point. So the other question, says determine the values of which the function g is increasing. Now looking at where g increasing, let's look at it. G of x, it increase, g increase if g prime of x is greater than 0. Where the gradient is positive, the graph is increasing. Now we're looking at this, where this is positive. So g prime is positive where? Above the x-axis. So meaning that from here to here, the graph is positive, the gradient is positive, because the graph is positive. That's my graph. That's where between here, this is where g prime is greater than 0. So the graph increase. So my 8.3, the graph is increasing when negative 1 over 3 is less than x less than 1. We can't say less or equals to, because here is where the graph is turning. It's not increasing or decreasing, it is turning. So the graph is increasing here. This side the graph is decreasing. Then let's look at this action 8.4. Let's look at 8.4. 8.4 is saying determine the equation this determine g prime. So that depends on what are we given here. If you go back to this, we're given the roots, here. So given the, what do we do? If given the roots, we're gonna say g prime of x, it is equals to a into x minus x at 1, x minus x at 2, because we are given the roots. Okay, I have my ax, this x at 1 and x at 2, these are the roots, and I should oppose the sign. The other ones was minus 1 over 3. I'm going to use positive plus 1 over 3. The other one was 1, so it's going to be minus 1. To get a, I'm going to pick up any other point on the graph. I have this point here where is 0 and 1. That point is on this graph here, so I'm going to use it. I'm going to have my 1, it is equals to a into 0 plus 1 over 3, 0 minus 1, which 1 is equals to minus 1 over 3a. Then I divide by, or I multiply by minus 3, which I have my a as negative 3. Then I have my equation as g prime of x is equals to minus 3 into x plus 1 over 3, x minus 1. So I have minus 3 into x squared plus 1 over 3x minus x minus 1 over 3. So we have minus 3 into x squared. This is going to be 1 over 3 minus 1 over 3 minus 1, which is minus 2 over 3x minus 1 over 3. Multiply inside by negative 3, so it's minus x squared minus 3x squared minus plus 2x plus 3. That's the equation. I've answered that. Then let's go to 8.5. 8.5, given that g of x plus 1 passes through this point, so then g prime of x is given by minus 3x squared plus x plus 1. Show that g of x a is equals to minus 3 minus 1 b whatever there, to show that that is equals to that. Okay, now then let's see how do we get this g of x. Now, looking at g of x, let's do this. Looking at g of x is given by ax cubed plus bx squared plus cx plus d. So I'm going to find g prime of x on that formula then. So which is 3a x squared plus 2b x plus c, and this, it is equals to this minus 3x squared plus 2x minus or plus 1. This one here is plus 1, sorry, this one is plus 1, not plus, it's plus 1, sorry for this one, it's plus 1. So I have this. Now I can see that my c is equals to 1. Then my 3a, it is equals to minus 3. Looking at this part here, so I divide by 3, a is equals to negative 1. Then my 2b is equals to b, I divide by 2, then my b is equals to 1. Now they said now that g of x, it was plus 1 should be passed through 0 and 0, meaning that when x is 0, y should be 0 if we add 1. So that's simple. I'm going to say now this g of x, which is minus x cubed plus plus x squared plus x plus d plus 1, it is equals to, this is g of x. That's what is happening here. So now when I put 0 here, I will get a 0 this side. So 0, it is equals to minus 0 squared plus 0 cubed plus 0 squared plus 0 plus d plus 1 is equals to 0. So that means that now, instead of 0 here, so I have my d plus 1 is equals to 0, then d is equals to negative 1. So I've showed that that's my answers. Thank you.